This is the device I'm going to use to manually gap the rings. This is a manual piston ring filer. I borrowed it from a friend. Thank you very much, Jeremy. One of the things I also did here is bolted it down to a piece of wood so I could clamp it to either a bench top or, in this case, a sawhorse. I don't want to be fiddling with the device while I'm trying to hold the piston ring down, so I'm taking one less thing to worry about away. And finally, before I start using the piston ring grinder, there was a little bit of wobble in it, and what I ended up doing is putting a Allen wrench in just to tighten it up slightly so that the wobble is minimized. You know, we're talking thousandths of an inch here. So, and I also want the piston ring profile to be as perpendicular and flat as possible. So just taking out any possible areas of variation. This is the part that I'll be using, or the parts I'll be using. This is a piston ring set from Hastings, and the part number is 2M139005. So the 005 means it's 5 thou over. 2M means that the top piston is steel moly. Now, I'm not sure if that's a iron under a moly coat or a moly coating or plating, or if it is truly steel. If it's steel, it's going to take a few more rotations of the grinder to grind it down. So I'm going to start with the top, and I'm going to start with doing 5 rotations of the grinder and then inserting it and measuring it. I'm going to measure it first. Where are we? And then I'm going to go from there. Inside the packaging, Hastings has labeled their piston rings so you have a good idea. Third comes in two parts. There's the oil retention ring and then the two shims, essentially, that hold the oil retention ring in. So I'm going to start with the number 1 and go from there. All right, here's the piston ring I just used to do all those measurements. I'm setting it up here where I'm going to take equal amounts off each time, each cycle that I do. I'm going to start with using 10 rotations of the wheel to see how much 10 comes off, and then I just multiply whatever I need off by 10, and I'll work my way up to it. So I'm positioning the piston ring against the pin and making sure that it is flat against the wheel, and then I'm holding it down, and I don't have to go fast, I just have to turn it, and we'll see how this goes. All right, get my technique. This is the first one. So I'm holding also this end against the pin. So I've got both against the pin, or both ends against their pins. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it looks like it was taken off pretty consistently, if I can get the camera to focus. There. Get it up closer to the lens. All right, now I'm going to just wipe off this, and I'll probably hit it with just a little bit of real fine sandpaper to make sure I don't have any burrs on that. Okay, so the first measurement, I went from about 9 thousandths to almost 11 thousandths. So I'm going to call it 1.1 thousandths per 10 turns. I'm going to do another 10 turns to see if it's consistent. And in this case, I've already cut this side. I'm now going to cut this side. So again, both ends of the ring against the pins. Hold down the side that's being cut. Top, I wasn't real consistent maybe in my counts last time. Top of the turn is 1 turn. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so now both sides have been filed. Again, I'll just touch it with some emery cloth to take any potential burrs or Klingons. All right, for the number 8 cylinder, started at 0.009 at the top, 0.075 at the bottom. I've taken approximately 1.5 thou off, so we should be around 10.5, 11, somewhere there. So sorry, 11.5. No, 10.5. So so that's a 10 and that's a 7. So I'm going to I need to take another 7.5 thou off. So at approximately 1 thou per every 10 turns, I'm going to again ease up to this. So that would be 75 turns. So I'm gonna do 30 turns and measure it again. That might give me a little bit more accuracy. Again, I'm easing my way up to this. All right, so I've figured out a conversion factor by doing some of these measurements here. So after 50 turns, I got an end gap of approximately 15.5, and of course I don't have an exact measurement because I'm working in thousandths instead of half thousandths. At the start, I had 9 thousandth end gap, so it increased by 6.5. Okay, so if after 50 turns, so at 6.5 thousandths after 15 turns means I get about 0.00013 removal of material every turn. Now, just because I've got some measurement error here, I'm going to start with the conversion factor of 0.0015 per turn. That gives me a 15% safety factor as an overestimate, so I don't overshoot. So I want to get to on number 18 here. I want to get at the top of the line here. I want to get to 18 thousandths. If I'm already at 15 thousandths, 15.5 thousandths, I need to add another 2.5. So what I'm going to do is start with 2.5 thousandths, divide that by my 0.00015. That says I need 16.7 turns. So I'm going to do 16 turns, do another measurement, and then again work my way up until I have confidence in my conversion factor. All right, I think I got my most efficient process figured out after doing the first 4 sets. So I've got pistons 2 through 8 with all their rings in them. Now I'm going to show you my process. First of all, I'm going to measure the gap at the bottom of the cylinder with the brand new piston ring. Then I'm going to subtract the target gap and that'll be the difference between those two is the amount of material I have to remove. And then I'm going to divide that material to remove by 0.0002, and that will calculate the number of turns. This is my first pass. I'm being conservative because I want to inch my way up to it. And then, so that's basically what I'm going to work through here now. I'll show you the process with piston number 1, or cylinder number 1, and how I'm doing the calculation. All right, so I'll put the piston or the ring inside of the cylinder, then I'm going to push it down with the piston, and if you can see that blue mark there, that's 3 3/4 of an inch below the top of the piston, which is approximately where the piston ring will be when at the bottom of the stroke. So let me go ahead and do that, and by using the piston, that'll center it and make it even all the way around. Okay, so now I'm doing that, and then I'm going to eyeball it from the side here as I push. There. Now the ring's in the bottom. I'm just going to make sure it's. I'm going to make sure it is bottomed out with the piston, and not sitting cockeyed, just by pushing from the bottom. There. Okay. Now I'll remove the piston and take the initial measurement, and this is probably going to be in the area of 4 or 5 thousandths. So I'll start off with 4 and work my way up. So I've got 4 on my gauge and my feeler gauge, and yeah, that went in. So I got to find if 5 goes in as well. There's 5. 5 also goes in, so we'll try 6. 6 goes in all the way. Okay, good. It's less material for me to remove. And I'll pull out 7 and 8. So 7 first. 7 does not go all the way. So I've got about 6.5 or thereabouts. So I'm going to start that as my my initial gap. All right, so I have a gap of 0.006. So subtract that from the target gap of 0.16, and then I get 0.10. Divide that by 2/10 or 2.0002, and that equals 50 turns. Okay. So I'm gonna use the file, the circular file, not the garbage, but the grinder. I'm gonna go a little bit less than 50 turns, and then I'll measure it and then ease up into it. Okay, hope you can hear me over the lawnmower next door. So this is where I'm gonna do 40 turns. And I basically make sure I'm up against the wheel, the grinding wheel, and the 2 pins here. And then I provide a force going towards the wheel as I turn the wheel. So ready? 1. 10. 20. 30. 40. Okay, so I've got a little bit of, if you can see it, there's a little bit of dust on the end. Pull that off. It's a little magnetic. And then I just, let me show you what I'm using. Just a honing stone, and I'm just taking the burr off the end. Without damaging anything else. And then Okay, now I'm going to stick it back down to the hole and get a measurement out of it. Okay, so this is after the grind, the initial grind, and my target gap is down in the hole, all the way down 3 3/4 inches, is 16. So I'm going to start with the 14, 15, and 16. And remember, I didn't go the entire 50 turns. I only went 40. So let's see what happens. All right, so I'm using the 15 right now, and that actually went all the way down. So let me try the 16. There's 16 right there. And yep, that went down. So some of the variation in the way the gap is done is how much pressure I put on the wheel. So I try real carefully not to use exactly what the mathematics say, because at least the theory, because I've got varying pressures as I'm working it through. So this one's pretty good. It's already at 16. That's what it needs to be. Now I'm going to pull it up to the top, and then I'm going to measure it. So it's 3/4 or 3/8 of an inch from the top, or thereabouts. Go get my engineering scale real quick. All right, so I'm just looking at it in 4 spots. Yep, they're good there. Got to pull it up there. Okay. Pull up a little bit there. I'm good there. Okay. Check once more, make sure I didn't mess it up as I pulled it up. Yep, that looks good. Okay, so now I'm going to measure what the gap is at the top, and it will be greater than 16. So I'm going to start at 19 just to... That went in real easy. 20, no problem. 21. Okay. Now we're getting into where I think it should be. Here's 22. Yeah, that went in tight. 23 should not go. Where is 23? Come on. There's 25. There's 23. Okay. Yeah, 23 did not go. So 22, I got 16 at the bottom and 22 at the top. Let's go check to see how we did. All right, based on my initial calculations, I wanted to have a file to the end gap down at the bottom of 16. That's what I ended up with. So that's bottom here and that's top. So I've got them flipped. So the bottom was 0.16. Should design my table better. And 0.022. Okay, so we're good with that. Now I'll do the same thing with the middle ring. And the middle ring, my target is 18 thousandths. So I'm gonna take a look at that and do the same calculations I did over here to hit that. And that'll be on ring 2. I won't take you through that because it's basically the same thing. The oil ring, I had actually originally said I needed to hit a target of a minimum of 0.015. That's not even a problem. The rings don't come even anywhere close to having a gap of 0.15. So again, that's minimum. So no problem at all. I'll just put them in as is without having to make any sort of changes. In this table is the data I collected after doing the filing of the end gaps. The way this table is set up is they're organized by cylinder number, and I organized the cylinder numbers by whether it's on the driver's side or the passenger side. So 1, 3, 5, and 7 are on the driver's side, and 2, 4, 6, 8 is on the passenger side. In the rows, I've got the data organized by the top ring measure and the middle ring measure. And the first row shows the measurement 1/2 inch from the top of the cylinder. So that's at where the maximum taper is, and at 3 3/4 inches from the top of the cylinder. So that's the bottom of the stroke. You'll see that for the top ring, I have targeted 16 thousandths end gap, and for the middle ring, I targeted 18,000 end gap. And you'll see that for the middle ring, I missed that target on 3 different rings. I want to thou over, but close enough. And you'll see also that for the top rings, there were in cylinders 5 and 7, the gap was a little larger than I would like, but that's the nature of what we're dealing with here. I've got a cylinder that has not been bored, and it does have taper in it, and that's what you get. What I can say is that these numbers are a heck of a lot better than what I measured, um, or heck of a lot better than what came out when I disassembled the engine. So there was a lot more wear in the rings, and there was a lot more gap. So even though these numbers are a little bit large in some areas, they're still better than when I took the engine out of the car. So it should perform better. It's not optimal, but that's what you get when you make the choices like I made to not have machine work done.